graph the given hyperbola. So there's a hyperbola. Okay, so how do we graph hyperbolas? Well, they're very similar to an ellipse. Imagine if that was a plus sign in the middle instead of a minus sign, that would be an ellipse equation, wouldn't it? With a 1 on the right side. It looks just like an ellipse equation, except it has a minus in the middle instead of a plus. That's the only difference between a hyperbola and an ellipse. So let's just imagine it had a plus in the middle and it was really an ellipse. What would we do first off? Well, what's the center? We need to start with the center. What's next to x and what's next to y? Nothing. So the center is 0, 0. There's no number next to x and y. If there was something up there like x minus 2 squared or y plus 3 squared, then we would know the center is not 0, 0. So let's get rid of those. Okay, so center 0, 0. And then whatever's underneath x, we rewrite that as 6 squared and 25 as 5 squared. And so that means now what's underneath x is always right, left, because x is right, left. So I go right 6 and left 6. And whatever's underneath y is always up, down, because y-axis goes up and down. So up 5, down 5. All right, now, this is exactly what we would do if it was an ellipse. Same thing for a hyperbola. Here's where it gets different. If this was an ellipse, if this was a plus sign in the middle and this was an ellipse equation, I would now draw the oval, the ellipse, wouldn't I? But this is not an ellipse. So instead, you make a box. Use those same points, but instead of making an oval, you make a dotted box. Now, why dotted? That means it's not really there. It's just kind of a guide to the graph. It's not really part of the graph. Whenever you put something dotted on a graph, you're saying it's not really part of the graph. It's just a guide for the graph. And then I'm going to start at the center, and I'm going to go through all 4 corners with a diagonal dotted line, another dotted line. And these are the asymptote lines. They're the guidelines. So starting from the middle, shoot through the 4 corners. That's why you made the box. So you would have the 4 corners so you could put in the asymptote lines. These are called asymptote lines. Okay, so now it's time to do the actual graph. How does the graph work? Well, basically there's 2 ways it could go. If you have x squared in the front, then there's going to be 2 branches that go, they start right at the edge of the box. Here's the dotted box. They start right at the edge of the box and go right and left. If you have y squared in the front, then let me put the box in first. Then they start top and bottom of the box and go up and down. It's all about what's in front. So for a hyperbola, which actually has a negative sign in the middle, not a plus, because of that negative sign, the way I like to think of it is the branches have a negative relationship. They turn away from each other. If the branches turn towards each other, they would make an oval, wouldn't they? That's the ellipse. The ellipse has a positive relationship. The branches turn towards each other, close in, and make an egg shape. But for a hyperbola, the branches have a negative relationship. They turn away from each other. So if x squared's in the front, it's going to go right, left, because the x-axis is right and left. If y squared's in the front, it's going to go up and down because the y-axis goes up and down. Which one do we have in the front? We have in the front x squared. So the branches are going to go right and left because x squared's in front. So starting in the middle of the box on the right, one of the branches, and it'll get closer to those asymptote lines forever on the right, and then over here on the left, it'll get closer to those asymptote lines forever. They're guidelines. They guide the branches. So there's the graph. Now, when you go to actually do it on Math Excel, you have to click 2 points. On the homework system, we don't have Math Excel. We're using the My Open Math. You click on the center dot. You have to click on the center, which will be the origin 0, 0, and then you click on the upper right-hand corner of the box, and it'll it'll make the box and put the branches where they belong. You see, the box, the dotted box, really is the holder or the guide for everything else, because the dotted box holds the asymptote lines, the diagonal asymptote lines, and then those guide the branches from the right and left sides of the box. So it's all about the center of the box and the upper right hand corner of the box, and then everything flows from there. How do you find the upper right hand corner? Over 6, up 5. Why? Over 6 because underneath x is 6, that's right 6, and up 5 because underneath y is 5. Let's go see it. Right 6, up 5. Here it is. So first off, you have to click on the bottom according to whether you're making branches go up, down, or right, left. Up, down, or right, left. Up, down, or right, left. We're doing right, left branches because x squared is in the front. So click your first dot at the origin, 0, 0. Your next dot, remember what it is, right 6, because underneath x, that's 36, 6 squared, up 5. So over 6, up 5, boom. I just clicked over 6, up 5. It made the dotted box, the asymptote diagonals going through the corners of the box, and the branches going from the right and left middle of the box going up towards the guidelines. The whole rest of the hyperbola comes from just those 2 points, the center of the box and the upper right-hand corner of the box. And so there it is.